So this is just more practice, 7.6 WSP. Let's jump to number 8. We're doing 8 through 22 even. So we have 2 to the x power. You want to solve for x. You want to get x by itself on one side, but the problem is x is an exponent. To undo an exponent situation, you're going to apply the inverse of an exponent situation, which is a logarithmic situation. So if you want to get rid of this exponent situation with base 2, you're going to have to apply a log with base 2. And of course, what you do to one side, you do to the other side. Sorry about the mess. Anyways, the log base 2 of 2 cancels out. The x comes down. The original inequality was less than, it comes down. Log base 2 of 25, let's just rewrite it. And guess what? You're done, right? All you got to do is type it into the calculator. Now, if you have the Casio, you type it directly in with the button that looks like this. So you just type it into that button. Of course, type in 2 into the base, 25 into the other one, hit equals, and that'll be your answer. Now, let's say you don't have the Casio. Let's say you have the Texas Instrument. You're going to have to change it because the blue calculator, the Texas Instrument, only does base 10 or base E, which is natural, the LN. So you're either going to use the LN button or the common log button. So if you wanted to use the blue calculators, I would use a change of base formula and either use the common log button or the LN. I want to use the LN button. LN on top, LN on the bottom. The bigger number, 25, goes up on top. The smaller number, 2, goes on the bottom, but it's a regular number. It's not a base anymore. And you should get the same exact answer. So if you're using this guy, use either the log button or the LN. I just chose LN because it's 2 letters instead of 3 when I write it down there. So LN, and it's when you hit, well, I use log, I guess, on this guy. So it doesn't matter, LN or log, you're going to get the same exact answer anyway. Okay. So maybe let's just say log, just so it'll look like what's on the screen up here. Log. Okay. Doesn't matter. Whatever. You're going to get the same answer either with the log button or the LN button. But if I go log 25, when I hit log, it's going to put the log with an open parenthesis. You're going to type in 25, but you need to hit this close parenthesis button before hitting the division, before hitting the division button. Okay? So log 25, you have to close the parenthesis with the close parenthesis button, and then hit the division, and then you could type in your log of 2. Okay? And if you do that correctly, you should get, so you should get that answer, 4.64385619, and it keeps going. So on your answer, you're just going to write x is less than 4.6439, I guess. So we have to also get kind of comfortable when we have a binomial as an exponent. Let's apply, how are we going to get this exponent down from there? Because you really have an a minus 4 up there. What could we do? Could apply log base 2, right? Anybody awake? So we're going to apply log base 2 to both sides. So log base 2 of 2 cancels out. We're going to have a minus 4 coming down. So from here, you're going to use your calculator. Again, if you have the Casio, you could just type it in with that button, log base 2 of 82.1. You're going to get a crazy decimal. And then after that, you're going to have to add 4 because you still have to get rid of this minus 4. Or, of course, you could change the base with the other calculator. You have to change the base because it doesn't do base 2. It only has a common log button or an LN button. So this right here, you could change it to LN of 82.1 divided by LN of 2. And, of course, you'd still have the a minus 4 right in front. So you'd have to add 4 to get rid of the 4 and then add 4 at the very end. So on your calculator, you would first do that, and I'm not necessarily put in parentheses, but you would type in ln 82.1 close parentheses divided by ln 2 close parentheses, hit equal. You're going to get an answer, and then add 4 to it, and that'll be your final answer. So you get that answer on the calculator, and I believe they want us to round to 4 decimal places. So it's only this in black. The 1 doesn't change the 3 to a 4. So I wrote that in blue, but it's what's in black right here. Number 22. So what could we do here? So number 22, I'm just going to go with it. I want to get rid of this exponent situation, so this comes down, yeah? So how could I get rid of the base 2? By applying what? Log base 2, right? So I'm going to put a log base 2 on the left, log base 2 on the left, and a log base 2 on the right, because whatever I do to one side, I do to the other. So I'm going to have, whoops, log base 2 over here also. So ladies and gentlemen, on the left side, the log base 2 of 2 cancels out. I do have n plus 1 coming down. The equal sign also comes down. Are you with me? On the right side, does the log base 2 cancel with the 5? Dang, it does not. So I have log base 2 of 5 to the 2n minus 1 power. Let me do it in a different color. 2n minus 1 power. Okay, so at this point, since log base 2 of 5 doesn't cancel, but it is a logarithm, and I do have a power up here, which happens to be a binomial of 2n minus 1, I'm going to use the power property to expand it, to bring down the 2n minus 1. So because it's a power, I'm going to be able to write it down here in parentheses with multiplication. So here's my new equation. 2n minus 1 in the front times log base 2 of 5. Now the log base 2 of 5 you could actually do. Okay, log base 2 of 5 you could actually do. We could use the button on the Casios, or you could use the change of base formula. If you go with the change of base formula, the log base 2 of 5 becomes ln5 over ln2, or log 5 over log 2. Hit equal, you're going to get a decimal, and the decimal is 2.32192, or 2.32193 if you round it up. So you really have the binomial 2n minus 1 times that irrational decimal. Now we still have the equals and the n plus 1 on this side. Now from there we're going to just distribute that disgusting decimal, 2.32193 times 2n. So that'll be 4.6439 n minus 2.32193. Okay, and of course it still equals, still n over here plus 1 over here. I'll be sad if I do all this work and we have the wrong answer. Anyways, let's subtract the 4.6439n and subtract the 4.3464. What am I doing? This is a mess. Space. So on the calculator, you're going to get negative 3.6439 n. And if we do 2 steps in 1, let's also subtract 1. So subtract 1 up here, cancel it, subtract 1 over here, and you'll get equals negative 3.32193. So at the very end, we're going to divide both sides by the negative 3.6439. Divide by negative 3.6439, and hopefully we'll get an answer. That's correct. So that's close enough to an answer right there. 0.91164, 0.19, or whatever. As long as it's close, I'll give you the credit. Let's jump to worksheet 7.7. 7.7. It says, so on number 1 says, write it as, this is logarithmic form because this is, after all, log base e. If you don't see it, you could go ahead and rewrite it. Maybe it'll clear it up a bit. Log base e of 50 equals x. Now, they want you to rewrite it in exponential form. Now, remember how logarithms work. It's always this base to what power gives you 50. This base to what power gives you 50. And that's exactly what it is. E to x gives you 50. E to the x gives you 50. So that's from logarithmic form to exponential form. Or like number 5, for example, that one's in exponential form and you want it in logarithmic form. So how would you change this to logarithmic form? you could apply log base e on both sides, which is really a ln, right? You could apply a log base e on both sides, which is really ln. That'll cancel out, and you'll have x equals log base e of 8. That's really ln of 8. So that's your answer, because it was an exponential, and now it's in logarithmic. Okie doke. Let's jump to some of these questions down here. It's the same exact concept. Number 13, what do? You're going to add 3. Add 3. You have 2e to the x equals 4. Then you're going to divide both sides by 2. And of course, we're going to get e to the x equals 2. Now, how do I get rid of the base e? Ladies and gentlemen, how do I get rid of base e? ln. So we're going to apply a ln to both sides. ln to both sides. That'll cancel it out. X comes down equals ln of 2. I don't know if they leave it like that or they actually type it into the calculator and get a decimal answer. But either way is easy. So let's jump to number 19. I want to bring down this exponent. I don't want this base e, so I'm going to apply a log base e. What is another word for log base e, or another phrase for log base e? ln, right? Natural log. So ln on the left side, ln on the right side, ln of e cancels out. You're going to have a new equation. 0.5x equals ln of 6. Now 0.5x is really 1/2 x. Now any calculator does ln, right? So you could just type this in the calculator, ln of 6, hit equal, and then after that you're going to have to multiply by 2 to get the x by itself, multiply by 2. So first do ln of 6 and then get an answer, which is going to be irrational, and then multiply it by 2 and you get your final answer. So with the with the calculator, you get that decimal answer, 3.5835. 27, you have ln, which is really log base e. So if you want to get rid of the log base e, because you see the thing is, the 2.5x is inside the logarithm base e. So if you want to get rid of log base e, what you need to do is take both sides of the equation, raise them up to be powers of base e. So the e to the ln, that cancels out. The e to the 10 is actually e to the 10. So we have a new equation that says 2.5x equals e to the 10. So e to the 10, you could actually do that on the calculator. You're going to get an irrational number. And after that, to get the x by itself, you're going to divide by 2.5 and divide by 2.5. So what I would do is do e to the 10 first, hit equal, get a crazy decimal, and then I would hit the divided by, and then 2.5. Hit equal, that'll be your final answer. And you should get that as a final answer, 8,810.58631. So you just leave the 3 right there, if you're rounding to the 4 decimal places. 31, super quick. We are going to use the product property because there's a plus sign to condense it. Both of those ln's are going to become one single ln. And of course we're using the product property, which means we need to multiply both of those. So 3x times 2x is 6x squared. Bring down the equals 9. And of course, to get rid of a natural log, you're going to raise both sides to be the powers of base e. So you really have e to the ln, which cancels out, and e to the 9th, that's the actual number. So we have a new equation that says 6x squared equals e to the 9th. Going to do all this math with the calculator. Divide both sides by 6, and then you're going to do the square root. So rewriting, I would do x squared equals e to the 9th over 6. I would do e to the 9th over 6 on a calculator, and then once you get that answer, I would take the square root of that answer, and your answer will be plus or minus the square root of whatever answer you get for e to the 9th over 6. So when you do e to the 9th over 6, you get 1,350.51398. It's pretty crazy, but then just square root that answer, plus or minus 36.7493. So that's how you do this. It's just a continuation of what we already knew, what we've already been doing. Study it. There's a test Wednesday, day after tomorrow.